Dr. G. Vishwanathan at Vellore. From its humble beginning, the institution has grown exponentially to that of having more than 33,000 students at present. Students from all the states of India and from more than 50 countries are studying at VIT. In recognition of its excellence in academics and research, the university status was conferred in the year 2001 by the Ministry of Human Resource Development, Government of India. VIT has retained #1 position among the private engineering institutions in India for the 4th year in a row. VIT is the first university in India to get a 4-star rating from QS, the international ranking agency, ISO certification from Holland, international accreditation from the United Kingdom and the USA, and the highest accreditation grade from the Government of India reflect the university's excellence in all fronts. Last year, the Government of India recognized VIT as an institution of eminence, IOE. This move from the Government of India to give autonomy to selected institutions of higher education in India, so as to encourage the institutions to take independent quality initiatives and move up in world ranking. VIT School of Design, in short, VSign, is one of the newest schools in VIT Vellore. It offers 3 undergraduate degree programs, namely BSc Multimedia and Animation, BSc Visual Communication, and BDes Industrial Design, and 1 postgraduate program, namely MDes in Industrial Design. It offers one of the best facilities in India for design research and training designers. To make further inroads in terms of collaborative participation in research and teaching, memoranda of understanding have been signed with Guangdong University of Technology, China, Canberra University, Australia, and we are in talks with 2 other universities from the US for signing MOU. We have faculty members drawn from best universities in India and abroad like IISc Bangalore, IIT Bombay, IIT Guwahati, NID Ahmedabad, NIT Tiruchirappalli, and University of Sao Paulo. We have adjunct professors from NTU Singapore, University of Kathmandu, Nepal, and Machakos University, Kenya. This conference is organized by the Center for VR/AR, a new center under the Department of Multimedia in VSign. This is one of the new centers started recently in VIT to augment research and development in the area of virtual reality and augmented reality. Already, 6 of our faculty members and research scholars are pursuing innovative research in this exciting domain. Present pandemic situation has forced all of us to go through a transformation in the mode of teaching and learning. It seems like we have been fast forwarded to our future now. This pandemic has forced us to learn and adapt distant learning technologies like never before. What otherwise would have taken 10 years for the new adaptation is happening in 2 months now. Newer ways of teaching and learning skills and knowledge are being experimented in large scale. Now, temporarily, the regular classroom learning has stopped. Distant learning, blended learning, smart learning, e-learning, and learning are the order of the day. New technologies like virtual reality, augmented reality, and mixed reality are enhancing the process of teaching, learning with more immersive experience. Virtual reality and augmented reality are the newer methods that are very engaging and take the learning experience to the next level. An international conference in this space is certainly the need of the hour. This will bring all the leading and the curious minds like you to come to a common platform and discuss the current trends and the recent advances in this field. Smartphones, from a tool for socializing to a tool for learning, learning. Now millions of school children are attending their online classes using mobile phones. My own daughter goes to school nowadays by sitting at home in front of a video camera wearing her regular uniform. There were times not long ago the teachers used to ask the students to switch off their mobile phones and keep them inside. Now, the same teachers are asking their students to attend their classes using mobile phones. This change has happened in the last few months, and it is here to stay even after the pandemic is over. These changes are transforming our lives. This new normal has raised more questions related to cultural, social, pedagogical, and technological issues. This virtual conference will attempt to answer all these questions. We have 5 eminent persons from Malaysia, Taiwan, Brazil, and India delivering keynotes, and 14 technical papers being presented through the day. I welcome all of you to have engaging sessions with intellectual deliberations throughout this virtual conference. Thank you. Now I invite Dr. Lakshmi Priya, the co-convener of this conference and HOD Department of Multimedia and Design, to give her insights into this conference.
Thank you, Professor. Good morning to all joined for the International Conference on Immersive Education with the VR/AR, organized by Center for VR/AR under the Department of Multimedia, VIT School of Design, shortly known as VSign, VIT Vellore, India. It gives me immense pleasure in welcoming you all for this virtual conference. I would like to take this opportunity to thank our management, Dean VSign, and faculty members who have joined together and gave us a platform to do big things in a better way. So since they have, without their support and cooperation, there is nothing to do with this conference. That's why we are here. So we have met around 400 plus participants across the globe from various countries like Morocco, Taiwan, Philippines, Malaysia, Brazil, and so on. So we are highly happy and delighted to have highly experienced keynote speakers from Malaysia, Taiwan, Brazil, and India, who are experts in the field of immersive technology. And we are lucky to have their graceful presence in this conference, who readily accepted our invitation to be part of the conference. As our Dean was correctly notifying the improvement and advancement in the technology, which made us get connected through this virtual conference. So as we are in the digital world, we make things in a different way. So this digitalization has brought us together, and it has created a platform to have a communication with the person who is somewhere else in the remote place of the country. Also, we have received around 24 papers, all technical papers related to this VR/AR domain. However, we have selected 14 papers out of this depending upon the reviewers' comment, and they have given a wonderful presentation with regard to their paper, and the papers were well organized, and it is very informative in nature. In addition to this, we have also received few few comments from the reviewers, wherein those comments have been incorporated in the papers by the presenters. In addition to this, apart from presenters, we have, as I already said, we have 400 plus participants across the whole globe who have registered for this conference. And I'm really grateful to welcome everyone for this conference. So in terms of virtual reality and augmented reality, it is an advancing technology where lots of improvements are going on, and making this growth has initiated us to establish a center for VR and AR by the help and support of our management. So this has been given an opportunity where Department of Multimedia is a part of this Center for VR and AR. And as our Dean rightly pointed, our faculty members are working on this and doing research in a better way for the better growth of our country. So I wish to deliberate this virtual conference where we have received papers related to blended learning, advanced learning, VR AR based learning, applications related to VR with education, training, and teaching. All this content enters into the field of the virtual conference. So I take this opportunity to thank our management and our Dean Visain for giving us an opportunity. And I welcome you all for this international virtual conference on immersive education with VR AR. Thank you for giving this opportunity. I would hand over the session to Professor Surendheran sir to introduce our chief guest and keynote speaker of the day.
Good morning. Thank you to each and every one of you for being here with us today. We are very pleased to be able to welcome Professor Dr. Vinesh Tiruchelvam sir, who is a Deputy Vice Chancellor and Chief Innovation Officer at Asia Pacific University, Malaysia, who has more than 20 years of experience in the field of engineering education, operations, maintenance facilities, design, and project management. He also served in the Middle East in 2005 to focus on his specialization in building services, property sector, that is designing and project delivery of sustainable energy and energy efficient buildings. He joined and took charge as a head at APU in Malaysia in the year 2012, managing more than 6,500 students and emphasizing focus on creating more industrial collaborations with ICT and engineering industries. His core scholarly research area are in sustainable development, reliability engineering, using smart devices with IoT, and data analytics with business intelligence. Now I request Professor Vinesh Tiruchelvam sir to start his keynote address.
Right, thank you, Professor Surendheran, and thank you to ICEVAR 2020 Organizing Committee for giving me this opportunity to speak at your conference. I think it's going on for the first time virtually. I hope you can hear me clearly. Yeah, and it's a true honor to be part of this conference. And also, I'd like to acknowledge congratulations to BIT for their recent success. I think it's mind-blowing that you have attained this status and this success at an international level. And I think when BIT first came to APU and I met them in 2014, that was part of that journey. I think it was the starting of that journey. And to having seen you reach this pinnacle, I'm quite proud to see an Indian institution reach the success that you have. Let me start by sharing my slides. And I want to share my slides for today so that everyone can view it. Yeah. Okay. So just to move on the keynote this morning, I basically represent four bodies. Yeah. So firstly, there is the Ministry of Higher Education in Malaysia. Then there is my own university, Asia Pacific University of Technology and Innovation, which has almost the same vision, mission, and goals as VIT. And then I also represent the Institution of Engineers Malaysia, and internationally I represent the Institute of Mechanical Engineers UK. I am also the Southeast Asia chair. By profession, I'm an engineer, so I've always been an engineer, will always be an engineer. But moving forward, engineering would not be the same without the infusion of technology. And my topic of the day is digital twins for engineering applications. And that's where I see the relevance with the current school or the department which is organizing this conference, which has the embedment of media, arts, and creative design for the applications in engineering. So I've been an advocate for digital twins not that long, but of late with the setting up of our own VR AR studio, which we have to talk about in the near future with Dr. Saleem, I guess, because we have the same mission in mind. I have come to a conclusion that digital twins are for real and they can be applied for engineering in a positive manner. So let me just go through these slides with you and also move on into the talk this morning. So what we have is actually the trends in engineering. So if I move forward to my slides, which is basically the current trends in engineering. So as you can see, these are the current trends in engineering. I'm trying to adjust myself to the screen so that I can view myself and also the screen so that I know where am I. Yeah. So if you see the current trends, right? These are the current trends in engineering. If you look at the items in red, cryogenics, 4D printing. Yeah, I know some are wondering why we're talking about 4D when 3D has just come in. But because of the evolution of technology, the technology and our state of exposure to technology, they're not on the same speed. Then you have digital twins, you got hyperloop, you got machine and computer vision, and also you've got some jet propulsion for the aviation industry. So these are different areas which are moving fast. And I'm going to focus on digital twins and how we actually can use digital twins in application for engineering. So having said that, right, if you look at the current trends, 2020 is going to be an interesting year for technological evolution. And why I say that is because what I've shown is the focal areas in engineering. But what you will see is, as per what Forbes has said, there are different areas of digital tech growth. AI as a service, 5G data networks, autonomous driving, predictive machine learning, computer vision, extended reality, for example, and blockchain. But the Internet of Things using sensors and devices is already changing the landscape for many industries. So these kind of smart technologies actually boost revenues for companies. And I think last year alone, it was estimated around the world that it boosted about US dollars worth of 344 billion in terms of revenue boost. And it's a direct cost shown as revenue from the infusion of technology and also from the embedment of IoT devices. Yeah. So IoT and smart devices are already increasing the performance metrics of many major factories, and they cover routine management issues and boost the productivity by about 40 to 60%. So that is quite a a vast change in productivity and annual sales revenue and all that. Now, if I move on to my slides and I go on to the next one, which is digitization and why does it matter? Now, when it comes to actually building structures, there's already a huge advantage for efficiency when manufacturers supply clearly structured 3D data for every component directly involved with the structure. Now I'm talking about a building structure, yeah. But in the medium term, new approaches to 3D engineering tools and configurators are necessary to combat the ever-growing workload in engineering. So the rapid demand for completion, the rapid demand for design changes. So tools and configurators must be intuitive, easy to use, and simplify complex tasks. Yeah, basically, and ultimately, there is a need to offer clear productivity benefits compared to normal and usual 3D solutions. So digital engineering ensures engineers that they have the right tools in hand, and one good example is the item engineering tool. Now, these tools actually help complete repetitive standard tasks much faster, and when working in a conventional CAD environment. So basic digital expertise and practical experience in 3D engineering will become fundamental requirements for engineers in the era of digitalization. So more and more companies are in the lookout for candidates and also research expertise in the area of 3D modeling. Yeah. And now, having said that, the pace is something that we have to be worryful of, and the rapid changing of business models, and of course, the complete digitization of everything that we do every day. Yeah. Now, the infusion of digital applications. Now, this is a thing that's already happening. Everyone knows this. Yeah. So, our world is rapidly becoming electrified, digitalized, and automated through smart products that are replacing analog and mechanical systems. So today's smart products are using electronic sensors, actuators, and communication technologies to deliver not only comfort and convenience in a consumer space, but also to improve employee efficiency, increase factory and production house utilization, to reduce unplanned downtime, and to enable predictive maintenance in the industrial space. So with so much riding on these products, designers and engineers need to ensure that they will perform as expected under the harshest of conditions. Yeah. So conventional design changes and challenges, you have to develop a wisdom to create truly innovative products that could be expensive and time consuming, but in contrast, using a physical build and test methodology. So engineering simulation enables product and designers to fully explore the design space and identify the most promising ideation or creation much quicker. So that's where we come to the formation of digital twins. Now, what are digital twins? So digital twins are basically virtual replicas of a physical device. Yeah. And when you can virtually replica a physical device, then on the virtual establishment, you can run simulations rather than the physical establishment. So there is no stoppage, right? There is no shutdowns, and these are built and deployed using the Internet of Things, sensors, devices. It uses a lot of artificial intelligence and analytics, which can optimize if you deploy the simulated outcomes to a physical establishment. Now, the virtual represents a product, basically. So the digital is a duplicate. Yeah. And within the digital twins, there is a marriage of two different elements. There is the DT instance and the DT aggregate. And with this, you can develop the DT prototype. Yeah. And in the prototype, it consists of a few elements itself. Yeah, it's got design, analysis, and processes that are built in to ensure that you can get a feel and realization as you augment yourself into the physical space of product. So this is basically a short introduction to digital twins. But I want to cover more areas of digital twins because I want to start with a clear indication of its value. So it's very, very important that one person understands the value in the creation of a digital twin, because to create a digital twin, the expertise, software, and time put in, it is not cheap. There is a lot of costs to be taken care of, and there must be an end outcome. Yeah. So what is the value? What we see now, basically, is the value that you see for the industry. So in terms of the industry, you can see oil and gas, you can see turbines for the power plants, and you can also see robotics for the application in manufacturing. Now, the key thing is that it's all about digital engineering. Yeah, it harnesses modern digital capabilities to improve an organization's efficiency and value. Now, how do you do that? You can only enhance process sequences and to transform end user experiences. So it's all about quickening and making processes which are in sequence more efficient, so that it tailor makes itself, it transforms itself so that it can reach the end user and sort of reach a successful UI UX. Yeah, with the appropriate resources allocated and the different type of models that we can use to deliver, and you project manage it perfectly, you can create a new business opportunity and customer value improvement. And digital engineering solutions can produce a continuous chain of innovation and competitive positioning. Now, this involves alongside customer needs and new technical opportunities. So what we actually want to contextualize the value is greenfield product engineering. Yeah. So a greenfield approach is to produce a product that provides the benefit of a modern and cloud native application architecture and a platform with microservices that allows for containerization, cloud enablement, and API driven development. So through this form of expertise development, organizations can adopt modern software engineering practices such as agile pods, lean startups, hypothesis and test-driven development. Now, the MVP increments, MVP means minimum viable product, and the DevOps are critical in ensuring there is extreme programming in place. Yeah. So this is the value that is brought by digital twins. Now, let me share with you a little bit about some of the applications to different industries. So if you look at the different industries, let's start with the most prominent one. So the most prominent one is very simply, is manufacturing. So in manufacturing, it is quite simple. Yeah. In manufacturing, it's all about the representation of telemetry sensed from a remote system that is rendered in real time or an offline playback. So in manufacturing, the key areas are digital twins don't have control over hardware, right? They only read and simulate, but they cannot control the actual physical establishment. But what they can do is provide valuable data and actual motion and commanded motion. Yeah. Now, this information is important simply because it is ideally suited for areas such as predictive analytics, AI, decision making, and then you can also have some kind of augmented reality interaction and teleoperations. So the potential applications for digital twins is quite broad, from the part of fabrication, assembly, testing, palletizing, robotic manipulation, and much more. So when machining a part, say for example, you have to machine a component, the digital twin renders an actual hardware motion that can be visualized via the machining operations from raw material to a finished component. So when using a robot for additive or subtractive manufacturing, the system's repeatability can decrease for several reasons. So a digital twin is important as a tool for comparative analysis. So as I've shown you there, a manufacturing process robot, a digital twin rendering of the robot work cell actually is based on using the actual motion produced by the hardware, which can be used to compare and validate the tasked motion sequences. This is important since many automotive work cells are actually multi-robot systems, and a lot of robotics is used in manufacturing nowadays, So to emphasize the extent of the potential application of digital twins, keep in mind the unarticulated systems that utilize digital twins, which can be modified, and that modification can be simulated so that it doesn't go to the real physical establishment, and based on the simulation, you can deploy. Now, I want to move on to another area, which is an area of smart engineering. So in smart engineering, you see that there is a few things that you can consider. Now, one of it is actually how does the cyber physical systems is connected in the driven twin, either physically or to the data-driven twin. So the entire connection within the cyber physical systems is important. So you can actually, there are a few areas here, you can deploy analytics for predictive learning. You can have AI and in-depth deep learning on your machine itself. And then you can deploy a lot of sensors and devices that can be used for data acquisition. And then you can have the functional mockup. So the functional mockup is actually a development at the digital twin stage. Now, also, before you simulate and you develop your digital twins, you have to use the CAE in terms of 1, 2, or 3D development. So that can actually be your order of modeling. So if you connect all of this, you actually deploy smart engineering to your manufacturing base. Now, the creativity of the simulations, the creativity of the 3D modeling, that's where the part of design arts comes in, whereby you infuse technology into basically duplicating what is there on the physical establishment. Now, what is the purpose? So I talked about the value and I showed you one or two examples in terms of manufacturing. But what is the purpose of digital twins? So the purpose of digital twins is very clear-cut. It allows for a descriptive illustration of what is there in a hardware, and you can take it from a remote state into an actual desktop state, and you can actually do a lot of descriptive analysis. Then you can do interrogative analysis. Now, interrogative basically means investigative studies. So if you have something that, which was going wrong with the machine, you can actually deploy a lot of interrogative, investigative on the twin itself, the duplication itself. And then you can do a lot of analytics. Now, analytics allows you to do a bit of prediction. So that's also predictive, but analytics comes in a few forms. One of it is diagnostic. So you can actually go down the history trail and find out what was the root cause. And then you can deploy some changes and predict outcomes. So all of this entire anticipated end results, you have the real advantage if you do it on a digital twin, because it can materialize what your expectations would want to be. And it is based on designing a model of this digital twin, which allows for real-time data feed as well. Okay, so this is important. So the real-time data feed comes in with two forms. Yeah, you have the cloud as an integration for data storage, and you have the devices that are secured on a network so that data can be communicated in real-time form. Now, this is another big area. So this area is actually the oil and gas area. And in the oil and gas area, it's a large area that actually has very good usage for digital twins. And I say that because oil and gas is basically harsh, it is remote, yeah, and it basically optimizes because the investment in oil and gas is huge. So in oil and gas, the Internet of Things has paved the way for significant efficiency gains. Yeah, and one concept that has garnered significant attention is the digital twin. However, there remains a great deal of confusion with regards to how digital twins can actually be used. And we see the pictures that I've shown you, the actual installation and the actual digital twin, which is basically a desktop view. Yeah. Now, some digital twins they are form of a 3D plant model. Yeah, but at times the industry says that you're missing out some components, but it gives you an advantage. Basically, the 3D can be immersive. That's where the VR, AR components come in. Yeah? The 3D can be immersive, and it's risk-free. So in an environment like oil and gas, it's harsh, it's dangerous at times. So it's hassle and risk-free. And the capability to detect faults early. So early fault detection based on what you have simulated, it allows for control limits to be enhanced. Okay. The objective is to demystify the digital twin. That is very important. When you demystify, you basically advance its capabilities. You can improve its competitive edge. So like an avatar for actual product, the twins actually allows oil and gas companies to visualize status and condition, which are miles away. So a lot of these oil platforms are deep into the ocean. Yeah, it allows for that. That is one area now, oil and gas optimization. Now, the other area is actually quite common as well, which is asset management. So asset management, basically any asset, and for this matter, let's look at buildings. Yeah. So you've got a physical asset and you can deploy the digital twin. Now, a lot of these assets, if you don't talk about new assets, let's talk about heritage assets or assets which are already been built. Now, deconstructing the digital twin concept into parts that provide a foundation for understanding the real digital twin. So a digital twin reflects the properties of physical assets, yeah, and the associated processes. For example, a 3D model or a first principle algorithm can actually characterize the real world asset, yeah. So operational data can be obtained as assets changes in terms of value, not value, commercial value in terms of the value of the property, but the value of how it is in terms of OPEX, yeah, operational costs. So these digital twins can actually help you in terms of the historical data. You can use that for simulation, and you can optimize the production of these assets. Now, digital twins actually can augment the design and construction of new equipment, asset restoration works, and the 3D model with a timeline. It can actually simulate an activity that identifies clashes or improves construction coordination. So some of these assets, they will have to go through renovation processes, restorations, and you may not know what is where. So the digital twin allows you to rapidly improve your efficiency in modification, construction, and asset management in terms of operations and maintenance. Yeah. So the classification of detection is important here, and a lot of assets now are actually going through this form of establishing a digital twin. Now, the other part about the digital twin is actually you can now deploy VR, AR, and you can actually don't have to visit the actual asset. You can augment yourself within the spaces of that asset. And a lot of it, actually we are doing now a replication of this for the Roman Colosseum, and how we have actually gone back in time, because the Colosseum was not built in a single day, neither was it built in about 10 years. It was over a very, very long period. So having the asset in terms of the construction duration from the time we dedicated the groundwork to the time they actually finished the Colosseum is something that you can augment yourself into that space, and that's what we're establishing now as well. And I think this is a great benefit of using a digital twin. Another area is actually the application in maritime, and in maritime, it improves your life cycle and accessibility to your maritime equipment, boats, submarines for that matter. And the digital twins is one platform that brings all the experts together, the experts from the maritime industry, the experts from the digital industry, so that they come together, and it can actually enhance information management and collaboration. Now, in the maritime industry, one area that we can look at is the cloud-based platform solution, where cloud stores all the ship's data. It can use different tool applications to analyze and develop models that can now improve fleet time and also the overall sustenance and maintenance of the ships as it is. Now, the life cycle of the ship, from design to decommissioning, the ship does not have a same life cycle as a car. So the ship differs, yeah. So using analytical and time domain simulation models in the form of digital twins allows you to update and refine the operational data. So now, based on sensor data as well, you can closely reflect the life cycle and improve the real asset performance. So all these ships are actually assets, yeah. And these are also based on many variables. So those variables you can also insert into your twin, and you can simulate the results. Now, these variables include weather conditions, waves, currents, and also the deployment of application for the vessel itself or the ship. Yeah. The other strong area of deployment now, of course, with the current situation of COVID and everything that surrounds healthcare, is the deployment of digital twins for healthcare itself. Yeah. Now, as far as I know, there isn't yet a deployment of digital twins for healthcare to analyze the human body in full, in entirety. Yeah. But progressions are there. I've read some documentation and research on that. So that's another area of evolution, basically twinning or cloning your body in a simulation form. But in terms of components or different parts of your body, yes, that's already going on. Now, there's a company called Dassault that actually developed a living heart. Now, what the living heart does is basically it produces a virtual model, yeah, of your organ. So in this case, the heart itself, yeah, and the software that is used allows for simulation of the blood flow, the mechanics, and also the electrification of the entire nerves that surround the heart organ. Now, if you use the proper software, you can actually turn a 2D scan of a human into a full dimensional model. So that is what a lot of parties are working on now to convert the 2D scan into a full model, which includes the heart as an organ as well. Now, capturing the entire human body will have multiple functional benefits for doctors, and I think it helps them prepare themselves for a surgery, because even though there are a lot of simulations done prior to a surgery, but now with a digital twin, you get the entire body in a functional state and almost in a real-time state. So just like the vessels and the robotics and the manufacturing, which we talked about earlier, you have a real state condition of a person, and you actually have a twin of the person, and you can actually do the operations on the twin, on the digital twin, and see whether it works out prior to actually deploying the actual physical operations. Yeah. Now, this is going to transform the healthcare industry, and I think there's also a French startup called Sim and Cure, which has done a lot of research in the medical area, whereby there is virtual representation of medical patients. Yeah, so they are also transforming healthcare within the digital twin concept. Yeah. Another area is, of course, the area of energy. So if I talk about energy, let's talk about the application of wind turbines. Whenever I travel India, I'm amazed by the number of wind turbines there are in many of the outskirts areas in the highlands. So these twins, which we say, these twins live in the cloud because they're so tall and they are huge. Yeah. Now these twins basically, what they can do is, if you have enough sensors and devices, you can actually collect data, yeah, and insights of how the physical twin, which is the turbine itself, yeah, and how you can deploy the technology in terms of endless, yeah, to test different conditions of how the turbine works, yeah, whether the wind is blowing harder, whether the wind blew at that velocity for how long, and or the wind did not blow at all. So that simulated results can be done. If you have enough map data, you can simulate those results. Now, it is important that when you simulate results, you can actually don't have to build the actual wind turbine, because building a wind turbine, simplistic design as it is not an easy task, yeah, and it will take time. So these are areas in energy which are quite important. But another energy question is that a lot of people ask, within the construction of the turbine itself, the turbine has got a block, as you can see, which is basically the heart of the turbine, where the yaw motors are, and that's where the generator is, and how you maintain temperature control within those within your control and your energy box. Yeah. So we use usually in engineering virtual sensors that can get temperature information, and that helps you monitor and estimate the physical health of the turbine. So now, some of the apps that has been developed helps the turbine work more efficiently once you get real-time data. And then you can also now again deploy this on your digital twin so that the real-time data is streamed in, the twin goes into motion based on the reflection of how the product is at that current physical state, yeah, and or the localized environment. So you don't have to be in that zone, that city, that area to do this. Now with a digital twin, you can do the deployment and the testing remotely. Now, in line with energy is power plants. So power plants are huge. They're also remote, just like the oil and gas industry, and they're hazardous, and it's a wide area. Yeah. Now, replicating the power plant, what was known as SCADA or DCS, which is a control systems, before. Now you have 3D modeling. So you have 3D modeling, which is basically the twin, which creates the essential model of the functional areas of the asset itself. And this is basically based on the physical methods and advanced analytics that can be used to ensure that your design limits are met for the power plant operations. And it's important that because the power plant as an asset is huge and it cannot go on a shutdown, because it is a critical and essential service. Yeah. So the models that are created as digital twins, it accurately represents the plant and the fleet under a large number of variations. So in a status of a power plant, there are many variables that come into play to allow the power plant to operate at a very high efficiency. Now, these models include, the fuel mix, the temperature, the ambient temperature, the air quality, the state of art equipment that is within there, how they work efficiently from a mechanical perspective, and also the forecasting of your output. And now you tie that in with your current market tariffs and things like that. And so that entire set of variables, they are now embedded into the model, the digital twin model. And with the sensor data that has been acquired, it gives you an ability to predict the plant's performance, evaluate the plant based on different scenarios. Yeah. And it allows you to understand trade-offs, which means you balance, you have a bit of minus and plus on different variables. And at the end of the day, it enhances your efficiency. And this is important. So what has happened in the power industry is that the deployment of digital twins basically has allowed for the inclusion of the capability to balance and optimize trade-offs. And that's important because this is at the moment has minimal visibility, because once they have minimal visibility, there is less control. So when they have the digital twin, they can have a bigger picture and the confidence to calculate commitments. And that helps them during unforeseen maintenance or any form of wastages. So what the digital twin does here, it actually allows for what if scenarios to be tested against business objectives and by creating the most informal or informed decision making process. So again here, it is a vital application for the power plant industry as well. I basically come to the end of my presentation, and what I wanted to do is actually show you the application of digital twins. Now, digital twins is not something new, but it is new enough because it takes creative design, modeling, in this case 3D modeling, and it replicates and duplicates the actual physical establishment. So it brings together two minds or two expertise. Yeah, it brings together the engineering field, which is used at the design and the operations of any physical device, but it brings in the virtual aspect, which is the twin. Now, from that perspective, you have creative arts and you have computing that now gets married together to produce the twin. And that transformation is important moving forward because it actually improves efficiency and there is a lot of valuable insights you can get your existing establishment, your physical establishment, so that you can do variable changes, yeah, without disturbing the current performance of any physical establishment. So I've come to the end of my talk. I can take some questions. I don't know whether I have time. Let the host let me know. But let me just end with a few words. Digital twins for engineering applications. It's a tech evolution. It's here to stay. I do strongly encourage the people and the experts in the creative industry to now come in and see how you can be an asset in this whole new world of digital twins for engineering applications. And I think it's going to grow even larger in terms of from a growth in terms of the industry itself. Yeah. I want to thank ICEVAR' 2020 Organizing Committee and DIT for giving me this opportunity to share some insights on the topic of the day and sharing my knowledge of what I have experienced. So thank you. And I'll pass you back to the moderator.
Dr. Vinesh, sir, thank you so much for spending your time. And it was one amazing presentation. We have actually learned a lot about the digital twins. That was very fitting topic that you have brought us today. And I know that how busy you are, and in the midst of everything, you actually joined hands with us in bringing this digital twins, a beautiful marriage between our lifestyle and engineering, manufacturing, and healthcare. So it was really, really nice to hear that. And of course, sir, this floor will be going to be open for our participants to ask a few questions towards the presentation and in the field of VR and AR to Dr. Vinesh, sir. I request the participants to post your questions in the chat window of the Zoom. And we do have a representative. I'm going to request Dr. Krishna Kumar, sir, to consolidate the questions and address it to Dr. Vinesh, so it will be easy for him. So the answer can be heard from all the participants. Thank you so much. Passing the control to Krishna Kumar, sir.
Thank you, sir. Hello, sir.
Hello.
So the first question asked by Dr. Lakshmi Priya, is digital twin technology something like what we do in simulation tools?
I mean, yeah, basically it's quite similar to any form of simulation that you do, but a lot of simulation which is done previously, it is a fixed simulation of a fixed establishment, but you do not have the operational elements within any moving parts within the physical establishment. So for example, I can simulate and I can model a car for that matter. Yeah, I can 3D model the car. I can even physically scale down a model and build the model, but I cannot do a simulation of the car in motion. What's happening with the digital twin is actually a physical representation of it being in motion. So it's not a fixed lockdown on the physical duplication. It is an actual replication or duplication of it in motion within a virtual perspective. Yeah.
Thank you, sir. Next question from Team, sir. In the absence of digital twin for an asset, how easy and time consuming it is for building a digital twin and address the issue in case of an accident?
Yeah, so one of the areas of benefit of the digital twin is actually to satisfy HSE, health, safety, and environment. So you can actually now address HSE issues when you deploy something on a digital twin. So if it breaks down or it fails, there is no implication of HSE onto a physical establishment. So there's no loss of property, loss of asset, loss of your manpower. So the trial and error is easier, and it definitely zeroifies your risk involved of any losses. Yeah, because you're doing it in a virtual perspective, which is in the digital state.
Thank you, sir. Another question from Murli Mohan, sir. Can you explain the use of AR/VR in education in this pandemic situation?
Right. I mean, the only way I can think of AR/VR in this pandemic situation, I cannot relate it 100% to COVID-19. I think COVID-19 is something we don't know what it is. We haven't determined what COVID-19 is. We know it's a virus, but we don't know how in depth the root cause for COVID-19. Yeah. But what we can do is if we deploy digital twins into the body replication of a patient, for example, then you could actually simulate your operational or your treatments prior to deploying the actual treatment onto the patient. Now in AR/VR, potentially you can augment yourself within the different components of the body to see in depth. If you use the digital twin, you augment yourself inside so that you can see the working function and how the body functions actually deteriorate based on a normal body function against a person who now has the virus. I mean, that's the top of my mind. I've never actually thought about how AR/VR can be deployed for in the COVID case, because it's still very new. There's still a lot of uncertainties around this current pandemic.
Thank you, sir. There's another question from Dr. Surendheran. Please let me know the usage of digital twins in waste management industry, which is a huge challenge.
Right. So waste management is two large words. If you talk about end-to-end waste management, that means from collection of waste to disposal at the end of it, which could be a landfill, then potentially I don't know how digital twins can be deployed. But if you ask me, for example, some of the technologies that we are using currently is the collection of municipal waste. So municipal waste is collected by trucks. It goes on a truck. It goes to, say, for example, an incinerator that burns the waste, and from the waste there is two outputs. One is energy in terms of cogeneration, and the other part is actually the wastages that come out as ash and precious metals from the burning of the waste. Then maybe that entire cycle, you cannot deploy digital twin on a process which is multiple process, which are based on basically different working functions. So you got disposal at point of the waste collection, then you got collection itself, then you got the logistics, and then you got the process of burning the waste. So you can actually deploy digital twins on the part of actually burning the waste, and that is a physical plant by itself. It is basically almost like a factory, yeah. But in actual reality, it's actually a power plant, because it's having cogeneration activities that actually has an end result of power being an outcome. So I think that in that part, yeah, you can use digital twins at the burning waste facility.
Okay, thank you, sir. I'd like to ask my own question.
Sure, go ahead.
Yeah. So, sir, you pointed out in INFUSION that the designers and the engineers need to work together for in virtual reality domain. So, how important is it?
I think moving forward, this blend of creative minds against the functional minds. Functional meaning the guys who are going to engineer it to make it work. Yeah. So the creative mind is basically the person who can now think how I can design it. I can come up with an idea and make it real, but I don't want to build it yet. So I make it real from a digital perspective, from a virtual perspective. Now that art of creation and using the tools that is required to showcase the virtual context or the virtual design, that may not be with the engineer. The engineer's function is to actually build and run it. So that comes with the term engineer itself, right? Is to engineer the end result. So when you bring it together, it is a perfect marriage. I think a classic example is one that we did at our university, and it was a perfect marriage between the School of Media and Arts and the School of Engineering. They took part in a competition where they were given a real model car from a local manufacturer, and it was a brand new car, and the competition was to actually futurize the car. That means come up with a futuristic design. So while the School of Arts remodeled the body of the car, the engineers brought in the functional elements. So the functional elements was to digitize the dashboard. So the entire dashboard now is fully digitized. To bring in IoT and computer vision, so that instead of using keys, now we go with facial recognition that opens the doors of the car automatically. So that perfect marriage between creative arts of modeling, but the entire modeling and the scaled down version to get the revised design approved was all done by the creative school. Yeah, and then the functional elements is done by the engineering school. So that marriage happened perfectly, and I'm quite proud of them because things are combining together. It cannot be in vertical silos anymore. It has to be working in teams. Yeah. So that's my answer.
Okay, thank you, sir. Thank you, sir. It's very informative. I like to, I must mention our deep sense of appreciation for Dr. Vinesh Tirthulam, sir, who has spared his valuable time in spite of his busiest schedule to grace the occasion. As a man of managing deliveries of international projects in so many countries, you have spared time to come over here and encourage us. Thank you, sir.
Okay.
Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. Your thoughts have enlightened our minds and have shown us an encouraging path. My gratitude to you, sir, for gracing the occasion and sharing your opinions today. Sir, I once again extend my thoughtful thanks on behalf of everyone of us for your very interesting and thought-provoking answers. Thank you, sir.
Thank you. Thank you. Thank you very much.
Thank you, sir. I will pass to Prof.Surendheran, sir.
Okay, sir. Thank you so much, Dr. Krishna Kumar, sir. And indeed, thanks a lot. Thank you so much, Dr. Vinay, sir, for your valuable time. And I'm going to request our Dean of DIT School of Design to say a few thank you words. And right after him, we are going to enter a very short break, and the conference will continue after that. Over to you, Saleem, sir.
Thank you, Dr. Vinesh, for this very wonderful keynote address. We feel very honored to have you here in this conference, sir. And we look forward to having more interactions with you in future, and possibly some collaborations with your university. Thank you very much for being with us, and we move forward. Thank you.
Okay, once again, sir, on behalf of the Center for VR and AR, Department of Multimedia under the School of Design, Dr. Vinay, sir, thank you so much again from our whole team. Thank you, Surendheran, sir, for getting in the contact. And on behalf of the participants, I think I can take the liberty to say thank you very much, sir. And yeah, so open announcement to all of them in the conference now. Based upon our schedule, we're right on time, and it was razor sharp. The presentation was delivered by Dr. Vinay, sir, right on time, everything. So, so based upon the schedule, you might already know that at 9:15, we would be resuming our conference again. So this feed will be disconnected at the moment, and please do join us again with the same Zoom credentials which we have given. Thank you so much. Thanks very much, guys. I hope you see all of you again. Thank you.
Thank you.